Hello and thanks for tuning in. This is a follow-up to the video I did on effectively cooling my SC846 chassis with minimal fan noise output. I'm building this system for a client and wanted to walk through some of the modifications in more detail than I was able to in my previous video. Let's start with an overview of the chassis stock configuration. The SC846 chassis comes with 5 80mm fans. We can see 3 on the central fan wall here and 2 in the rear. These fans have hot swap caddies that they're mounted into that make it very easy to replace should they fail during runtime. You can see that each of the fans has a short cable with the PWM plug mounted on the side of the caddy. Then they slide right into their spot and plug into the cable. With the same feature on the fans on the back, PWM connector attaches to a plug here that then goes to a cable that runs to the motherboard. Unfortunately, with the modifications we'll be doing, we are going to lose the hot swap functionality on all of these fans, but that shouldn't be an issue. We're using high quality Noctua fans that should last years, if not the entire lifespan of the server. Next up, we have the ventilation holes on the sides of the chassis. We can see some on the opposite side as well. These are designed to keep the stock high-speed fans from starving under certain circumstances, but for our purposes we'll be sealing them up, making sure that all of the air coming into the chassis will be drawn in through the drives, thus maximizing the cooling that we have. Thankfully there are no ventilation holes on the bottom of the chassis to seal up, just on the sides. Next, we have our power supplies. The stock power supplies that come with the chassis are typically very loud. Supermicro does make a quieter variety of power supply, PWS 920SQ. Very easy to swap in and out. The power supplies that we have in here are actually those quiet variety. They can slide in and out like so. And you'll see the serial number, or rather the model number, listed right here. Let's replace them. Just slide right back in, and then the handle folds out of the way. The last thing we want to take a look at are the drive sleds themselves. Now typically these would obviously be populated with hard disks. The air would go in through the slots in the front and the hard disks would be cooled. But in cases where you might not be populating all of the hard disks, you'll have empty space there that could potentially serve as a kind of bypass for the cooling air for the hard disks. So a lot of times the drive trays will come with these sleds pre-installed in them to block the air from flowing through empty drive trays. If the chassis that you get does not have these trays pre-installed, you can always use some tape to seal up the inside of the sleds so that you don't have air bypassing the hot drives. So let's go ahead and start the modifications. These can really be done in any order, but we'll go ahead and start with the fan wall since it is certainly one of the largest tasks. So the fan wall is secured in place by several different screws, many of which cannot be accessed unless you remove the hot swap fan caddies. So we'll begin by taking those out. There's 1, 2, and 3. So now the first screws that we'll remove will be on the sides. We have 2 screws here and here. Note that we also have 2 screws for the intrusion detection switch. You can go ahead and leave those alone for now unless you want to remove the intrusion detection switch. The second set of screws that we'll remove will be over here. So let's go ahead and get those out. With the side screws removed, the fan wall is free to move around except along the bottom. We have 4 screws that we will need to remove in the next step. Here's a better view of the 4 remaining screws along the bottom of the fan wall. Obviously we need the stock fans out to be able to access them. But once they're removed, we can see that we have the first screw here The second is here, the third, and the fourth. So we'll go ahead and get those out now. With those last 4 screws removed, the fan wall should now be able to slide free. This space that the fan wall occupied is almost exactly 360 millimeters wide, which will be perfect for the 320 millimeter fans that we're going to put in this space in a couple of steps. There are a couple other things to do before we actually mount the new fan wall in place. The first thing we need to do is remove the intrusion detection switch that we see here. This is removable by these 2 Phillips head screws. While it's not strictly necessary to remove this switch, it does make it a lot easier, but if you want to keep it in place, you can probably figure out how to work the fans in around it. The next thing we need to do is over here, there is a tab that was used to mount the stock fan wall in place. Those were actually the first 2 screws that we removed. This needs to be cut off or bent out of the way. I tend to find it's easiest to just cut it with a Dremel. The cutting does tend to make a lot of sparks, so to keep everything safe, I like to remove the backplane PCB and cover up all of the power supply wires and the ventilation for the power distribution unit that's housed in here. The PCB for the backplane is fairly easy to remove. There are 9 total Phillips head screws. We see 4 running along the top here. Then there's another 5 running along the bottom. And obviously we'll also need to remove the Molex power connectors that we see down here. So we'll start off by removing those, and then we'll take a look at the actual cutting process. Here's a view of the inside of the chassis with the backplane removed. The backplane, after removing all of the screws and the Molex power connectors, will slide out of the chassis vertically, like so. It turns out, in addition to the 5 screws on the bottom of the backplane and the 4 on the top, there were actually 2 on the right side of the chassis wall here and here that can be accessed from the outside of the chassis. But with the backplane out of the way, we can start preparing for the cut. We'll start by taping up the vent holes for the PDU here, and we'll tape the power supply cables back to keep them out of the way, and then we should have a clean area to make the cut for the tab here so that we can fit the fan wall into place. So I'll get that taped up and we'll check back. So after a liberal application with some masking tape, we have a pretty good environment for making our small cut. Again, the tab is right here. The main issue, the main concern with the sparks is not so much the heat generated by them, but the fact that it's a kind of dusty, conductive material. So if some of that dust managed to find its way into the PDU, it could potentially be sucked up by the fans and cause a short circuit somewhere. So in addition to taping up these vents, I taped up the backs of the drive trays. This is probably excessive, but again, because this is a client system, I don't want to take any risks. I'll also note that we have the wires from the power supply taped back to keep them out of the way. The sparks probably wouldn't hurt those outside of some minor cosmetic scorching, but it's better to keep them out of the way. So we'll go ahead and make the cut and take some sandpaper to it to smooth it out and see what it looks like. So now, as you can see, I have the tab cut. I took some time to sand and buff out the edge so that the finish here is smooth to the touch. A couple steps remain before we mount the new fan wall. We'll go ahead and replace the backplane. For this build, I'm actually going to be using a different backplane than the one that I took out in the previous steps. After that, we can go ahead and construct the fan wall with the zip ties and then mount it in place. So before actually installing the new replacement backplane, I thought it might be worthwhile to just take a look at how the actual PCB and its mount are removed from the chassis. Again, we have 11 total screws. You've got 5 running along the bottom, 4 along the top, and then 2 on the sides here. Once you have it free, it can be a little bit tricky to get out. There is a trick to it. You sort of scooch it over to one side, and then it pulls straight up. The tabs along the bottom will just barely clear the PCB here for the front panel connector. And once you have it out of the way, you can go ahead and put the replacement backplane in the same way. The new backplane that we're using is the 846A, which is going to be a direct attach backplane rather than the port multiplier based backplane that we just removed. So we'll go ahead and get that secured and move on to the next steps. While we're getting the chassis put back together, I thought it might be worth taking a quick look at some of the screws that are used throughout the case's assembly. Most of them you'll be able to very easily visually distinguish between. For example, the two on the left both came out of the backplane. The shorter, stouter one is used on the bottom row, and then the taller, thinner one is used on the top row. However, the two on the right both came out of the same spot on opposite sides of the chassis and appear to be almost identical. However, on closer inspection, you can see that this one has a slightly shorter thread pitch than the one on the left here. This one is also slightly narrower in terms of its diameter than the one on the left. So just make sure that you're keeping track of which screw came out of which hole, so you get them put back in the right spot and you don't damage screws or any of the threads. So we have the backplane mounted in place. I have the SAS connectors hooked up as well. They're just dangling on the other end, obviously. We want to do everything that we need to do on this side of the fan wall before actually mounting the fan wall, because it's tough to get your hands down there after the fan wall is in place, and removing it can be a pain. So in addition to the SAS cables, I've also mounted a PWM fan splitter that will hook up to the fan wall and also to the front fan shroud. To connect to the front fan shroud, we run a PWM cable through the side of the chassis and up underneath. In order to fit it through one of the vent holes, we actually have to remove the connector here. So let's take a look at how to do that, and then we can feed it through the holes and get it hooked up. Now we have here a PWM splitter. Obviously it's not the extension cable that we're using the actual build, but the connectors are identical, so the process will be exactly the same. We have the jacketing around the cables removed, so we can see the individual cables, which we'll need to remove the connector. We're going to be working on the female end of the cable. It has these holes cut out that reveal the tabs that need to be depressed to pull out the cables. So basically what we're going to be doing is pulling on each individual cable while using a small flat blade screwdriver to push the tab in. It's a fairly straightforward process, but it does take a little bit of fidgeting around in there to get it to come out. So let's see if we have some luck. Okay, so there's the first cable that comes out. We can see the shape of the terminator on the cable has this little triangle shape here. This is what you're actually pushing down, and then there's a clip on this side that clips into the top of the connector. So repeat that process for the other three cables, and then we'll be good to go. Here's cable number 2, or rather wire number 2. Here's number 3. And wire number 4. So now we have the connector removed. At this point, if this were the extension cable, we would take the individual wires and feed them through the vent holes in the side of the chassis, and then we can reconnect this connector. Reconnecting them is a lot easier than connecting them, or rather disconnecting them. Basically, we just need to slide the wires back into the connector, and then they'll snap back in place. The only tricky thing is we need to make sure that we have the pin out correct, so you have the pins going into the correct slots. You can refer to the other side of the cable if you want a guide, or if you have another PWM cable with an intact female connector, you can use that as well. But basically we'll start with the black cable here. Again, the shape of the connector has this little triangle, so if we have the connector with the cutouts facing upwards, that triangle we want facing downwards. And then we'll go ahead and slide that into place. Next, we will have the yellow cable. Again, slide that into place. And you'll hear a little snap. The green cable comes next. And then finally the blue cable. Test to make sure all the connectors are secure. And this one is good to go. If you have a cable that does not sit tightly in its connector and sort of wiggles its way loose as you're tugging on it, you can just bend the little metal clip on the end of the cable so it provides a little bit more tension to the clip inside of the connector. The new fan wall is now assembled. Very easy to do. Just use some zip ties to tie the fans together. It makes for a pretty rigid structure. I have double-sided tape zip tie mounts along the bottom that I'll use to secure it into place, and then a couple on the side over here. I put these in on the fan wall in advance of installing it in the case because it makes it a little bit easier to get everything in place. And the ones over on the left side of the fan wall give us the right amount of clearance to get everything in there tight. And then we just have some normal 3M double-sided tape on the right side. The PWM cables are run along the bottom of the fan wall underneath the zip tie mounts. And then they'll exit on the drive side of the fan wall and then be run underneath through the little cable channels down underneath the fan wall. So obviously to mount it, I'll remove the adhesive backing and then just slide it into place like so, and then run the cables. Obviously we still have a space left up here that needs to be sealed up. I'll use a piece of wood. I'll take the measurements and cut it and then zip tie it into place and use some duct tape to make everything look nice and get everything sealed tightly. And again, then the fan cables will run under the cable channels underneath. I'm not actually going to mount the fan wall until the very last step. I'll get the rest of the system completely built just in case I need to access anything on the drive side of the fan wall. It makes it a little bit easier without having all of the bulky fans in the way. So in addition to having the fan wall constructed, we also have the side vents sealed up. On the left side, we have 3 sets of vents. There's some underneath here, under here, and then a few down on the bottom. And on the right side, there are 2 much smaller sets of vents. We also have the PWM extension cable run for the front fan bezel. This will be mounted up underneath the chassis to provide power to the 340mm fans up there. Let's take a quick look at how we can replace the fans in the rear part of the chassis. As we saw in the first part of the video, there are 2 80mm fans mounted to these hot swap caddies. The caddies can be removed by depressing the tab here, and then they slide right out. The fans themselves have a very short PWM cable with the connector mounted to the side of the caddy and held in place with this little clip. So to remove the fan, you can start with the 4 standard fan screws, and then the tab here can be removed by prying off the clip, like so. The connector slides loose, and then the fan can be removed. For replacement fans, we're using 80mm Noctua fans. I have them mounted into the caddies, screwed in place. Then the cable is fed through the hole that the original cables went through. There's obviously some extra slack on this cable, so I have it folded up over top, then fed back down through the connector, or rather through the clip, and then the clip holds it in place. Before actually mounting it, we need to remove the extension cables from the original fan mount. That can be done with the clips on the underside. The connectors come loose very easily, and then the new fan can slide in place with the PWM cable being routed through the little hole occupied by that extension cable. We obviously repeat the same process for the second fan, and then we're all set. So now we have the fan wall assembled, but not yet mounted. We have the ventilation holes in the side of the chassis patched up with duct tape. We have the cable routed for the front fan shroud, and we have the 80mm fans in the rear of the chassis replaced with quieter models. We'll go ahead and complete the build and then finish up the cooling modifications after all of the system internals are installed. So I have the chassis pretty much assembled now. There's just a couple things left to do. There's going to be a scratch disc mounted over here. I need to run cables for that. Also need to mount the strip of wood that's going to seal off the fan wall. That'll be the next step. I also need to take the 3D print fan shroud, sand and finish that. You can see that the 3D print comes back fairly rough, especially on the underside. So I use a lot of sandpaper, some high build primer to fill in the cracks and get everything smoothed out. Then I'll mount the fans and use some weather stripping on the fan shroud itself and on the front of the chassis to get everything sealed nicely. I already have the cable run for it, so I'm going to go ahead and sand this next. I'm going to cut the strip of wood and then finish running the cables, and we'll check back in after that's done. This is the piece of wood that I'm using to seal the top of the fan wall. It's a simple piece of pine that I cut to size. I cut a notch on one side so that the piece of wood could slip under the little lip on the side of the chassis wall. I used a square to mark exactly where each of the zip ties would lie and cut a little slot for them to sit in so that they don't interfere with the seal on the lid. Then I secured the fan wall in place with the zip ties and trimmed the ends. On my own system, I used a piece of duct tape to get a tighter seal against the bottom of the chassis lid, but for this build it didn't end up being necessary. As we'll see in the next steps, I used some sandpaper to smooth out the top of the piece of wood, and then I painted it black so that it would blend in with the rest of the system. So the chassis modifications are all complete. The build is all finished. The system's configured. I configured an OpenVPN VM for remote access and set up the operating system with all of the configuration necessary. In terms of the cooling modifications, really the only thing different from my installation was for the seal on the top of the fan wall here. On my system, the strip of wood that I used was a little bit lower, and so I used duct tape over top of it to create a tighter seal against the bottom of the chassis lid. When I tried to do that with this fan wall, it ended up making the lid far too difficult to slide backwards because of the friction against the top of the sort of rubberized duct tape. So rather than using the duct tape, I just sanded this down to make it relatively smooth and just painted it black so it sort of blended in with the rest of the system. As you can see, for the wood strip itself, we've got a couple slots cut in it that allow the zip ties to sit nicely in place. There's also a slot cut right under here that allows the wood strip to slip underneath the sort of fold on the side of the chassis wall. So all in all, it creates a pretty tight seal. The chassis lid is still a little bit tighter than on my system, but it's certainly very manageable. In terms of the other modifications, obviously we sealed up the sides of the chassis wall. We replaced the fans in the back and installed a beefy air cooler in there. I have the system wired up for a scratch disc over here, which is not yet installed. And of course, the final major modification was the creation of the front fan shroud, which we'll take a look at in a moment. In terms of wiring for that, we have a 4-way splitter, PWM fan splitter over here. So 3 of those connectors go to the 3 fans on the fan wall, and then one of them will go to another 3-way splitter that sits inside of the fan wall. That sits inside of the fan shroud that's going to be along the front of the chassis. So let's take a look at the fan shroud and see what that looks like. So the design for this fan shroud is very similar to the one that I have on my own system. A few minor differences that we'll go through. First, you can see that rather than using zip ties to secure the fans and the fan guards in place, I'm using nuts and bolts. This allows for a much more secure installation. It also resolved the issue of not having anything to loop the zip ties around in the four corners. On my original design, I had implemented or added a little slot sort of that the zip tie was supposed to loop around, but that didn't end up printing very nicely. So I just removed that from the design and used nuts and bolts for everything. On the rear side of the fan shroud, again, very similar, but we have a little bit more space down here that I added for the wiring. I found on my own design the wiring interfered with the very front of the drive trays towards the bottom of the server, so I added a little bit more room down here, and also removed the cutouts for the little zip tie mounts because they didn't end up working. I do have zip tie mounts on the little tabs that we see here and here to hold all of the wiring in place, and the fans obviously connect to a three-way PWM splitter. I have the connectors for the fans and the splitters zip tied together. Sometimes they tend to work themselves loose, so I just have them zip tied for a little bit better security. Obviously, I've also got the weather stripping around the front, or around the back of the fan shrouds that will create a nice tight seal against the front of the chassis and allow the air to go through the drives rather than escape through the sides of the fan shroud. And then, of course, the PWM connector comes out towards the bottom here, and this connects to the little extension cable that I have run along the side and the bottom of the chassis. As we saw in the previous video, the fan shroud is secured using zip ties that will feed into the little slots that we see in here and be secured to the handles on the front of the chassis. So basically what we have in here, hopefully get a good view of that, I have a 12-penny nail that I took and sort of slotted in there, so something like this, and then I used a Dremel to basically cut off the head of the nail and the point of the nail, just leaving the shank, basically a steel rod that we run in there, and then add some CA glue on the top to get that secured so it won't go anywhere. So anyway, the system is just about complete. I'm going to package it up and ship it out. Thanks very much for watching, and hopefully you found this video informative. If you're interested to learn more about this build, I'd invite you to check out my website in the description text below. Please feel free to reach out to me via email or Twitter if you have questions, or if you're interested in having me build a similar system for you. And thanks again for tuning in.